Okay, so this is part 2 of partial pressure for related equations for Chem Class 38. Number 4. Hydrogen gas was collected over water at a pressure of 102.5 kilopascals and a temperature of 25 degrees Celsius. After sealing the container, it was heated to 210 degrees Celsius. What is the final pressure of the dry hydrogen gas? Well, in order to find the pressure of the dry hydrogen gas, you have to subtract the pressure of the water vapor from the hydrogen gas because some water vapor is always pervading the hydrogen gas. Um, you can look at the table that I put on a previous slide to find the partial pressure of water at 25, or of the water vapor at 25 degrees Celsius, which correlates to 3.2 kilopascals. So you just need to subtract 3.2 kilopascals from 102.5 kilopascals in order to get 99.3 kilopascals. In order to convert from degrees Celsius to Kelvin, you just need to add 273. So temperature 1 equals 25 degrees Celsius plus 273, which equals 298 Kelvin. T2 equals 210 degrees Celsius plus 273 equals 483 Kelvin. Because everything else is constant, you can use the equation P1 over P1 over T1 equals P2 over T2, and then just plug in what you calculated or what you were given. So 99.3 kilopascals over 298 Kelvin equals P2 over 483 Kelvin. Then you just need to rearrange that equation to solve for P2, and you get 160.9 kilopascals. So the final pressure of the dry hydrogen gas is 160 kilopascals. Number 5. Oxygen gas was collected over water at 30 degrees Celsius. The pressure in the 2.5 liter container was 110 kilopascals. If the container was allowed to expand to 7 liters and if the temperature was decreased to negative 30 degrees Celsius, what is the final pressure of the dry oxygen gas? Well, as the same thing as before, you have to find the pressure of the dry gas. So P of total, the pressure of the total minus the pressure of the water vapor is 110 minus 4.2 because 4.2 kilopascals correlates to 30 degrees Celsius from the table, and that equals 105.8 kilopascals. The temperature is 30 degrees Celsius plus 273 equals 303 Kelvin, and temperature 2 equals negative 30 degrees Celsius plus 273, which equals 243 Kelvin. You can use the equation P1V1 over T1 equals P2V2 over T2 because everything else is constant. So then you could just plug in what you calculated or what you were given, and you get 105.8 times 2.5 over 303 equals P2 times 7 liters over 243 Kelvin. Then you just rearrange that equation and solve for P2, and you get 30.3 kilopascals. So the final pressure of the dry oxygen gas is 30.3 kilopascals. A quantity of oxygen, number 6. A quantity of oxygen gas was collected over water at 30 degrees Celsius in a 475 milliliter container. The pressure in the container was measured to be 105 kilopascals. How many grams of oxygen gas were collected? Same as before, you need to subtract the water vapor from the oxygen gas in order to find the pressure of the dry oxygen gas. 4.2 again is the pressure that correlates to 30 degrees Celsius, so you can just do 105 kilopascals, which is the pressure of the total gas, including the water vapor. Subtract the pressure of the water vapor, which is 4.2 kilopascals, and that equals 100.8 kilopascals. Then, in order to find the molar mass, you know that the mass of an oxygen molecule is 16 grams per mole. But since oxygen gas is O2, you have to multiply that by 2, and you get 32 grams per mole for the molar mass of oxygen. Since there are 1,000 milliliters in a liter, you have to divide 475 milliliters by 1,000 in order to find the volume to be 4.75 liters. And then you just add 273 to 30 degrees Celsius to get 303 Kelvin. Then you can plug those values into your calculated and given values to MPV equals MRT, and then just rearrange the equation to solve for M. So you get 32 times 100.8 times 0.475 equals M times 8.31 times 3.303. So M equals 0.608 grams, so you know that 0.608 grams of oxygen were collected. Thank you for listening. I hope you learned something.